The Silent Witness. China's Tianwen-1 reveals secrets of the third interstellar visitor. Imagine this. For months, astronomers across the globe have been glued to their screens, hearts pounding with anticipation, as the scientific community teeters on the edge of a monumental revelation. Telescopes from NASA, the European Space Agency, ESA, and observatories in every corner of the Western world have grappled with relentless challenges. Blinding solar glare, swirling atmospheric dust storms, and the unforgiving geometry of our own sun's position. Earthbound eyes, for all their sophistication, were forced into temporary blindness during the most critical moments. But high above the rusty dunes of Mars, one spacecraft held steady, its gaze unwavering, perched in the perfect orbital sweet spot. No excuses, no interruptions. Just pure, unfiltered clarity from instruments designed not for headlines, but for unvarnished truth. That spacecraft? China's Tianwen-1, the trailblazing orbiter that's been circling the red planet since February 2021. And now, as of November 6th, 2025, the long wait is over. China has unveiled the first high-resolution images of the interstellar comet 3, I/ATLAS, snapped from Mars orbit during the exact window when every Earth-based telescope was sidelined. These aren't just snapshots, they're a cosmic bombshell, blending ultraviolet scans and dust plume monitoring to expose facets of 3I/ATLAS that shatter long-held assumptions. Stick with me through this journey, because by the end, you'll see why these images aren't closing the book on interstellar mysteries. They're ripping out the pages we thought we knew and starting a whole new chapter. Let's rewind to the heart of the drama, the geometry that made all the difference. Discovered on July 1st, 2025, by the NASA-funded Asteroid Terrestrial Impact Last Alert System, ATLAS telescope in Chile, 3I/ATLAS burst onto the scene as the third confirmed interstellar object to grace our solar system, following the enigmatic Oumuamua in 2017 and Borisov in 2019. Right from the start, its hyperbolic trajectory screamed outsider, hurtling through space at an astonishing 58 kilometers per second relative to the Sun, faster than any of its predecessors. With an orbital eccentricity of 6.14, the highest ever recorded for such an object, it wasn't looping around our Sun like a local comet. It was a straight-shot visitor, slingshotting past at speeds that defy easy capture. By early October 2025, as 3I/ATLAS swung within 28 million kilometers of Mars on October 3rd, the alignment was poetic. Earth's observatories, including NASA's fleet and ESA's ground stations, were crippled by solar elongation, the angle that plunged the comet straight into the Sun's overwhelming glare. Atmospheric interference scattered light like confetti, and dust storms across key viewing sites in the Northern Hemisphere only compounded the chaos. Attempts to track it from Earth would have been like trying to spot a firefly in a supernova's afterglow. Enter Tianwen-1, China's first independent Mars mission, launched in July 2020 as part of the ambitious Tianwen series. Orbiting at an altitude of about 400 kilometers, it positioned itself in a segment that offered a pristine, unobstructed line of sight across the interplanetary void. No solar interference, no horizon haze, no earthly distractions, just the cold vacuum of space in a high-resolution imaging camera, HIRIC tuned for precision. While Western missions suspended direct tracking, Tianwen-1's instruments hummed along uninterrupted, capturing data during the comet's approach to perihelion on October 29, 2025, when it dipped to just 1.4 astronomical units, about 210 million kilometers, from the Sun. This was the make-or-break phase for comets, the time when solar heat triggers sublimation, unleashing jets of gas and dust, revealing tail morphologies, energy bursts, and potential fragmentation. Traditional models predicted chaos for an interstellar wanderer like this, a violent breakup under thermal stress, much like the ill-fated C2019Y4 Atlas from 2020, which disintegrated spectacularly before reaching its peak. But Tianwen-1 didn't record pandemonium. It witnessed poise, a structure that held firm, brightened unexpectedly, and accelerated in ways that left modelers scratching their heads. As the China National Space Administration, CNSA, emphasized in their release, while Earth saw shadows, Mars saw the spotlight. This single fact, the orbiter's solitary vigil, flips the script on how we chase cosmic secrets. It's a reminder that in the vast theater of space, sometimes the best seat in the house isn't on our home planet. Now dive into those first frames and prepare for the goosebumps. At a glance, the initial image from Tianwen-1's high-ret camera might seem underwhelming. A faint, streaking dot amid a star field, captured between October 1st and 4th, 2025, from a distance of roughly 29 million kilometers. But zoom in with the eyes of an astronomer, and it's electric. The data reveals a robust dust coma, not the wispy, dissipating haze you'd expect from a high-speed interloper, but a thickening envelope, symmetrical and stable, encircling the nucleus like a cosmic halo. Ultraviolet sensors aboard Tianwen-1 clocked a UV reflectivity spike that synced with rotational models, yet the amplitude was off the charts. Too intense for a nucleus estimated at 5.6 kilometers across, suggesting spin rates or reactive surfaces that push the boundaries of known physics. And the tail? Measurable even from Mars orbit, it stretched into an ion tail with intricate structure, glowing brighter than forecast by a full magnitude. Early ground-based observations from Atlas had pegged it at magnitude 17 upon discovery, but Tianwen-1's photometry showed fluctuations in a rhythmic pattern, periodic brightenings that weren't random noise, but a deliberate cadence. Patterns like this in interstellar objects? They're the universe's way of whispering, pay attention. As one ESA report noted post-release, these observations refined the comet's trajectory by a factor of 10, turning fuzzy predictions into laser-focused paths. But the real jaw-dropper? No signs of the fragmentation that should have torn it apart. Instead, coherent jets erupted sunward, forming directed plumes rather than a chaotic spray. It's as if 3I/ATLAS was engineered for resilience, defying the thermal shredding that claimed its 2020 namesake. These images don't patch a data gap. They dynamite it, forcing us to question if our comet blueprints need a complete overhaul. As 3I/ATLAS hurtled closer to the sun, the plot thickened, and Tianwen-1 was the only one keeping score. European ground stations went dark, their solar elongation rendering direct imaging futile. NASA's Hubble and James Webb Space Telescopes, while powerhouse tools couldn't pierce the glare without risking instrument overload. Earth's collective sigh of frustration echoed through observatories from Mauna Kea to the Canary Islands. Yet from its Martian perch, Tianwen-1 had the golden angle, above the ecliptic plane, sidestepping the sun's obstructive blaze. CNSA's documentation drives this home with a phrase that chills the spine. Mars was the only eye left open. In real time, between October 1st and 7th, the orbiter tracked the birth of new jet structures, elongated dust tails unfurling millions of kilometers, an anti-coma plume blooming faster than any simulation allowed. Traditional models built on decades of solar system comets forecast a messy outgassing, a diffuse spray of ice and rock under solar assault. But here was directed release, coherent streams aligning with axial precision, as if guided rather than exploded. If a comet behaves like this near perihelion, the CNSA report cautions, fragmentation must follow, yet none appeared. This wasn't mere survival, it was adaptation. Photometric data from Tianwen-1 logged a 0.3 magnitude surge in brightness without a hint of structural collapse, a paradox that echoes through every section of the analysis. Classical physics demands that such energy jets expose vast surface areas, implying a nucleus riddled with impossible real estate, hollow chambers, layered composites, or, dare we whisper it, something not forged in a comet nursery at all? The orbiter's instruments, cross-verified with ESA's Mars Express and ExoMars Trace Gas Orbiter, a TGO data from the same window, paint a unified picture. An object pulsing with vigor, its coma harboring not just dust, but hints of suppressed reflectivity. A dark ridge slicing through the glow, axially aligned with the jets. Traditionalists balk, but outliers like Harvard's Avi Loeb, who once floated Oumuamua as potential tech, now point to this as circumstantial backing for structured anomalies. Fear isn't in the data, it's in the implications. Why the hesitation from CNSA before release? Because revelations like these don't just stir debate, they unsettle foundations. Peel back the layers, and Tianwen-1's suite of sensors sings in harmony. There's architecture in the chaos, not artifacts or optical tricks, but tangible form, a density fold or thermal shadow within the coma, repeating across frames like a signature. The report speculates on geometric occlusion, but avoids the elephant. Could this be a non-spherical nucleus, etched by eons or intent? Then comes the stunner that keeps experts up at night, a sudden brightening from the anti-sunward side. Comets sublimate toward the heat. They don't ignite from the cold flank. Yet on October 3rd, as 3I/ATLAS grazed Mars' vicinity, Tianwen-1 recorded what researchers termed unexpected photometric inversion, a pulse of reflected or emitted light from the shadowed hemisphere, as if internal processes stirred in sync with solar input elsewhere. This wasn't passive melting. It evoked activation, a response defying ice and dust dogma. NASA's MAVEN orbiter, dipping into Mars' upper atmosphere during the same pass, corroborated with halo detections of gas and dust, but Tianwen-1's UV and dust monitors added the twist. Carbon dioxide richness atypical for our system's comets, hinting at a home star system bathed in different cosmic rays. Post-release, Western agencies scrambled to backfill the gap. Hubble's July 21, 2025, image showed a fuzzy coma at 277 million miles from Earth, while JWST's August 6th spectroscopy flagged spectral quirks from billions of years of radiation. But the resignation is palpable. Earth's monopoly on skywatching has cracked. Tianwen-1's jets mismatch Western hydro models. Its brightness tweaks orbital solutions. The absent fragmentation upends acceleration data. The tail's geometry screams incompatibility with a monolithic core. The verdict, unspoken but inevitable. 3I/ATLAS isn't just visiting, it's evolving, adapting under unseen rules. Hollow? Fragmented, yet cohesive, or powered by physics we haven't mapped. The orbiter didn't just observe, it democratized discovery, proving that rising space powers like China can eclipse old guards when the stars align. This tale crescendos into something profoundly reflective, almost elegiac. Here we are, peering at an artifact predating our sun by up to 14 billion years, born in the Milky Way's thick disk, a relic of galactic antiquity, through machines scarcely older than a grandparent's prime. The irony bites. China's inaugural interplanetary probe, Tianwen-1, snags a rewrite of interstellar lore just as ESA's Comet Interceptor gears up for future intercepts. We anticipated dusty ice balls, passive drifters from stellar nurseries. Instead, Tianwen-1 gifts us intense shadow, jets too precise, brightenings too timely, structures too insistent. The images don't unravel the enigma. They amplify it, shifting the lens from Earth's crowded skies to Mars' solitary gaze. For the first time, our planet wasn't the protagonist in its own story. Blinded by the sun we orbit, humanity ceded the view to a robot from another world, built by a nation that engineered persistence where others paused. Yet the deepest unease isn't the inversions, or the ridges, or the plumes carving voids across space. It's not the whispers of Loeb's alien probe hypothesis, echoed in an October 2025 Arg paper musing on non-gravitational nudges sans outgassing, nor the mass loss over 13% near perihelion, per NASA's post-perihelion tracks, mirroring but exceeding natural ejections. No, the haunt lies in the void Earth endured, modern astronomy's virgin blind spot, where home soil failed as witness. Tianwen-1, unblinking amid solar fury, became our proxy eye, a testament to global collaboration as CNSA shared raw data with NASA and ESA, fueling trajectory tweaks that armed telescopes for its December 19, 2025, Earth fly by at 1.8 astronomical units. The images returned aren't comfort food, they're a gauntlet. No tidy comet obeying rote rules. This visitor shifts, pulses, defies fragmentation mandates, amasses energy in forbidden ways. It's less cosmic flotsam, more echo of order. Ancient, perhaps deliberate. CNSA's sparse prose, the numbers laid bare, anomalies adrift, thunders louder than fanfare. No bold theories, just questions. What did Mars truly behold? Why did 3I/ATLAS dance differently under one watchful lens? That query now haunts labs from Beijing to Pasadena. Not alien, outright, that's social media's siren, but natural at all. Did cometary laws, etched over centuries, miss the mark for forge farther origins? Lacking Oort cloud chaos, bereft of stellar system scars, it bears intense imprimatur, unfakeable in the void. Tianwen-1's bounty leaves us teetering, a natural oddity from Sagittarius direction, or harbinger of engineered wanderers. The world holds breath not for spin, but for sequels. Next drops from SOHO's coronagraph glimpses or STERERO's tail chases, anomalies that might veil rip or mystery multiply. One lesson gleams. Discoveries dawn beyond blue marble. Revelations won't pause for readiness. They'll arrive via Mars orbit, demanding we evolve to meet them. If this cosmic thriller has ignited your wonder about what Tianwen-1 truly ensnared, those rhythmic flares, the shadowed structures, the unyielding core, don't let the spark die. Hit subscribe. The sequel images from ongoing tracks could upend interstellar dogma overnight. Bell notifications, because when the next frame beams down, you'll crave front row awe. And drop your verdict below. Garden variety comet from another star's nursery? Or did Mars just frame humanity's premiere glimpse of interstellar craft? Your thoughts fuel the discourse. Let's unpack the stars together.